Hey team, Frank here. Very excited to walk you through some of the POC work we've been working on in enabling data streaming between Salesforce and AWS for the purposes of powering our new data infrastructure. So really quick, today we are using Salesforce as our system of record for all of our borrower operations, and in fact for our borrower experience as well to a large degree. As we evolve our borrower experience, more and more of that is going to live on the AWS side. But both the AWS side and the Salesforce side need to be able to share data with one another and ultimately drain all of that data into a place that our risk and data teams can actually make use of it for building analytics and prediction intelligence for our machine learning models. So what we're working through is a new architecture that's going to involve streaming and moving data between Salesforce and AWS so that we can create a single centralized repository of data that we can then transform and load into Snowflake for our data team to be able to work with. Now, this POC is quite involved. There's multiple facets to what we're doing. But first things first, we need to start liquidating data in real time or as close to as we can from Salesforce to a data store that's a little bit more scalable and a little bit more capable of supporting mass transactionality, mass transformation, and more. So what we're leaning on is some new technology from Salesforce called EventRelay, which is a first-party integration between Salesforce event infrastructure and AWS's native event infrastructure, and in particular, the Event Bridge service. What happens here is we can enable platform events on the Salesforce side to stream through the EventRelay to the Event Bridge on the AWS side with simple configuration. This allows us to create a real-time stream of events between the two platforms, and in particular, of change events on records from the Salesforce side. So this means if one of our agents makes a change to a record, we can actually stream that change in real time through Salesforce's infrastructure into AWS, and then take all kinds of different actions on it. Now for this particular scenario, what we're going to do is ultimately write that information to S3, and we're going to do that through Kinesis. So I'm going to walk you through how this is all set up and some of the options that we worked through here. First things first, it all starts inside of Salesforce. So Salesforce has a feature called Change Data Capture. What Change Data Capture allows you to do is pick from your custom objects and a handful of standard objects and basically toggle on change events. What happens here is as soon as you select one of these entities, in this case I've selected the scorecard, every time there's an update to one of those entities, a change event is going to be created. Now a change event is basically a JSON document, if you will, of the details of a record. So in this case, what you will actually get is the list of everything that changed when you made a change to the record. This is super useful because that information can then be used to make changes to a core system of record that exists outside of Salesforce, say another database inside of Amazon. In this particular case, I made a change to the notes field, and that new value shows up in the change event. So turning that on is great, but we actually have to get that over to AWS. So what we do here is we set up a named credential that's going to allow us to connect our Salesforce instance to our specific region and account on the AWS side. When we've done that, we'll be able to then stream events over to the AWS platform. Now, once we've set up the named credential, we have a little bit more work to do on the Salesforce side. Unfortunately, this work can only be done with the API today, as there is no user interface for this config, but I can walk you through the basics. What you're looking at here is Postman, which is a helpful tool for making API calls to services like Salesforce. And Salesforce provides a whole collection of API endpoints and subsequent queries that you can build off of in a Postman collection. Now we've modified this for EventRelay, and I'll walk you through the different calls. The first thing we have to do is create an event channel. So this is a channel that events are going to flow into from the Salesforce side when we actually start making changes happen. So you can see here I've just set up one for scorecard changes. We then are going to subscribe a member to that channel. So in this case, we're going to subscribe the change events for when we change a scorecard to the channel that we've created. So here you can see my entity is the scorecard change event, and there's a change event object created for every object that you enable CDC for. And then we're actually aligning that to the event channel we created in the previous step. Then what we're going to do is actually create the event relay. So this is really, really simple. This literally just associates an event channel to a destination resource, which may look very familiar. This is our named credential. So we're aligning our event relay to the named credential. Then what we're doing is making sure that we've actually got things set up correctly. So we do a quick query, and we can see now that the resource has been created. And here we actually have the unique representation of that resource that's been provisioned on the AWS side. The last step is then to just patch our event relay and turn it on. Once we've done that, events will begin to flow to the event bus that gets automatically provisioned on the AWS side. Now, the cool thing about this is all of this, aside from the API calls, has been done without code. However, we need to do something with these events once they hit the bus. So that's where we have the opportunity to set up some rules that allow us to direct some of that traffic. And in the case of the event bus that we've created for the change events, we actually can set up a rule to drain those events to Kinesis. Now, Kinesis is the AWS suite for event streaming. And I won't bore you with all the gritty details, but the setup here is pretty simple. You create a data stream, which is basically going to receive all those events. So here you can see we've started to receive events from those changes we made. And then you create effectively a delivery stream, which puts those events somewhere. In this case, we're actually writing those events out to S3. So now, when we go into S3 and go into our repo before, we can see we've got a new collection with the events that are streaming in over time. And if I were to download one of those, what you would find is exactly this, a JSON doc that basically we can parse and now use Airflow or other tools to land inside of Snowflake. This is the very beginnings of our infrastructure and really just represent this core part of the puzzle here, where we are streaming data to Event Bridge. Now, one last bonus thing, not only have we set up event streaming, but we've also used Amazon's declarative data integration tool called Amazon AppFlow, which also allows us to do the same thing. So this is where things get kind of interesting. AppFlow gives us another option, which is to effectively define a flow that is going to use the Salesforce APIs, connect to one of our environments, target a particular object, and then move that data to S3 directly. This can be set to run on demand or on a schedule, and it can even be triggered based on event. We have the options to then map specific fields, which gives us a little bit more power. And in fact, we can even opt to add newly imported fields automatically, so we don't have to worry about schema drift. We have the ability to define how we structure that inside of S3. And in fact, we can even determine, based on our overall configuration, whether we want this to be full transfers or incremental transfers. When we use this particular approach, what we end up with is a very similar structure inside of S3, where our record data that we are streaming in ends up inside of an object folder with a representation of each record by ID and the full JSON payload representing all of the fields and the data in those fields at the time of the sync. Now, because we can set this up on a 1-minute sync, it's effectively pretty close to real time. So as a team, when we begin to solution for 2.0, we're going to want to choose the best poison here for our overall strategy. That said, between the two, our streaming approach and AppFlow for a more traditional kind of polling and ETL approach, we have a lot of options here. So this is great. This is a lot of progress for us and really going to be a critical part of our infrastructure and of enabling our data team going forward. Thanks very much.